Today we're going to spend a little bit of time verifying rational expressions. And verifying a rational expression is very similar to what we did last year when we verified trig identities. So when we did trig identities, we worked with one side all the way through to make it look like the other. For verification of a rational, you pretty much use the left side and make it look like the right side. So we want to take this stuff here on the left side and make it look like this over here. And it kind of gives you an idea of what you're looking for when you look at the answer. Notice we're looking for a quantity of 4x minus 1, and we're looking for a quantity of 3 minus 4x. Well, I notice the 3 minus 4x is right here. And I'm looking for the third. Well, notice we have a third power and a fourth power. When I factor out the GCF, I end up pulling out that third. So let's go ahead and work with the left side of this and see if we can't get it to the right side for that verification. So first thing, remember again, we're going to go ahead and combine these monomials, 2x squared, the 4, and the negative 4. So it gives us negative 16 times 2 gives us a negative 32 x squared. We have our 3 minus 4x quantity to the third. To that we're going to add, there's no monomials over here, so we just have our 4x times 3 minus 4x to the fourth. Again, we will make it look like the right side there, so we're not going to mess with it. I'm going to go ahead and find my common factors, my GCF. So I've got 32x squared, I got 4x. So it looks like my monomial is going to be a 4x. I have a negative out here at the 12. So I'm going to go ahead and see, I see a negative there, I see a positive there. I might as well go ahead and pull out that negative. It looks like I'm going to need that. And then I'm going to take out this quantity of 3 minus 4x to the third. So let's see what we have left over. Negative 32x to the second divided by negative 4x gives us an 8x. The 3 minus 4x to the third is gone. 4x divided by negative 4x gives us a negative 1. And we have 3 minus 4x to the fourth, taking out 3 of them. We're left with 1 of them. So now I've got my negative 4, well, I got a negative, and I got my negative there. I got my x and my x. I have my 3 minus 4x to the third, so that's good. I'm going to go ahead and underline my negative and my x so I don't mess with those. So now let's go inside this bracket and clean it up. So we got negative 4x, 3 minus 4x quantity to the third. We have 8x minus 3 minus a 4x, so it gives us a positive 4x. So we'll end up with a 12x minus 3. Looks like we're almost there. So if I take my 4x minus 1, if I multiply that by 3, I would get my 12x minus 3. So if I pull a 3 out of this, multiply it to the 4, I get my negative 12x. So I get my negative 12x times 3 minus 4x quantity to the third times 4x minus 1. So I've got my left side equal to my right side. So I have verified that equation. And we can do these as long as you want. You can look at as many examples as you want. Some things that we're going to see this big quantity to a negative exponent. Remember, negative exponents to a fraction are going to flip that fraction. And we can break that into 2 positive 1/2 powers. We can also in here clean up inside the bracket. And with inside the bracket, we can clean up the numerator. So let's go ahead and see what that's going to look like. We have 1/2. I'm going to flip or reciprocate this fraction. So 4x plus 1 to the positive 1/2 divided by an x plus 2 to the positive 1/2. To that, we're going to multiply. I have 4x plus 1 times 1. That's just 4x plus 1. I'm going to multiply a negative through and a 4 through. So I get negative 4x minus 8. So my 4x's are going to cancel each other. 1 times negative 8 gives me a negative 7. Ooh, I like that. And then the denominator is going to stay the same. 4x plus 1 to the second. Well, now if I look, I have my 2 in my denominator. I have x plus 2 to the 1/2 in the denominator. I have my negative 7 in the numerator. So I just got to work with these 4x plus 1s. I have a 1/2 on top, 2 on the bottom. If I think about this, 2 is going to be actually 4 halves. So if I subtract the, oh, I guess I made a mistake when writing that example. It should have been a 3, shouldn't it? So if I subtract those exponents, 4 halves minus 1 half gives us 3 halves. So I get my negative 7 over 2 times the quantity x plus 2 to the 1 half times the quantity of 4x plus 1 to the 3 halves. And that one is a verification as well, if I wrote down the right problem. Another one here, some negative exponents to work with. Again, we can take those negative exponents, take them to the bottom of that term. So we have 1 divided by 2 times x plus 1 to the positive 1 half. To that, we're going to add 1 over 2 times the quantity of x minus 1 to the 1 half. So it looks like I'm going to find a common denominator since I've added those together. My common denominator, I have 2 and 2 in common. I'm looking at an x plus 1 to the half and an x minus 1 to the 1 half. Those are different, so they're going to be part of my common denominator. So my numerator, again, remember we're looking to see what does this denominator need to make it look like the common denominator. So I have a 2, I have an x plus 1 to the 1 half. I need an x minus 1 to the 1 half, so I'm going to multiply that to the top. On the right side, I have 2 and an x minus 1 to the 1 half. I need an x plus 1 to the 1 half. And lo and behold, there we go, we got it. Done problem. Exactly the same. And I have just one more, just to kind of play around with it. So up here, again, we have some monomials that are being multiplied together. So we can bring these two together and get an 18x. Get rid of those. We have a 4 and a 2x, so we got an 8x. Get rid of those for our monomials. Common denominator for our monomials would be 18x and 8x. For that would give us a 2x. Oh, I like that. If we look at our binomials, we have x squared plus 1 to the 4th. Here we have x squared plus minus 1 to the 3rd. So I can take out 3 of those. If I have 3x squared plus 1 squared, and I have 3 of them here, I can pull out 2 of those. And let's see what we have left over here. So we had, oh, I didn't put my 3 on there, did I? So we had 4, oh, sorry, it was monomials first. We had 18x divided by 2x gives us 9. We had x squared minus 1 to the 4th. We're pulling 3 of those out. So we're going to be left with 1 of those. And the 3x squared plus 1 squared, we're taking both of those out. Minus, we had 8x as a monomial. We're taking 2x out. So we have a 4. We had 3x squared plus 1 to the 3rd. We're taking out 2 of those. So we have 1 left. And x squared minus 1 to the 3rd, we're taking all 3 of those out. So that's going to be our leftover pile. And this is over x squared minus 1 to the 5th. Now we have common factors on top and bottom. Remember, this x squared minus 1 is being multiplied to the 2x and this quantity and this quantity. So I can cancel 3 of those out, which they have in common. That leaves me with a squared on the bottom. Inside the brackets, I have 9x squared minus 9. When I multiply my 9 through, multiply my negative 4 through, I get a negative 12x squared minus 4. So cleaning this up, looks like we got a 2x, which is almost what we want. We want a negative 2x. We have 3x squared plus 1 squared, which is exactly what we want. And over here we have 9 minus 12. That gives us a negative 3x squared. And negative 9 minus 4 gives us a negative 13. And again, that's all over our denominator of x squared minus 1 to the 2nd. Again, good heavens, I was bad writing out my examples, wasn't I? So that should be x minus 1 to the 2nd. Oh, sorry, no, that was an 8. Yeah, that was a 5. So this should just be a 5. I had a sloppy 8 there. So it was to the 8th, and I want it down to the 5th. That was a sloppy 8 that I wrote up here. All right, so we can pull out a negative for our negative 3x squared minus 13. pull that out. So we get negative 2x times 3x squared plus 1 to the second times 3x squared plus 13 divided by x squared minus 1 to the second. And there we go. And that's a couple of examples of verifying. So again, we want the left side to equal the right side, working with just one side. Good luck.